In this video, we're going to add and subtract rational expressions. And as you're looking at some of these problems that I'm scrolling down through, you're probably thinking, oh my goodness, what have I gotten myself into? Well, no need to fear. It's actually very similar to the stuff that we were doing in the past when we were adding and subtracting just regular fractions. So the rule is exactly the same, okay? And it is this: you must have the same denominator. You must have the same denominator. That's still the rule whenever you are adding or subtracting fractions. So that's why we practiced with regular fractions before we got into the rational expressions. Now, if you're looking at this first example, which I want you to copy down, you'll notice that the denominators are the same for both of these fractions. Well, that's great. That means we can subtract them. So let's do just that. We've got 2 times k plus 2 in the denominator, so we'll keep that right there. And then in the numerator, we have a k plus 3 minus a k minus 3. So this is the part where we have to add like terms or combine like terms. Now, we did this a while ago, and you should still know how to do it, but just in case you forgot, there is a 1 in front of the k here, and there's a 1 in front of this k right here. And then when we have a negative sign in front of something like this, where we have parentheses, we have to make sure to distribute the negative sign to both the terms inside the parentheses, or else we're going to get it wrong. Okay, so now really we just have to combine all the like terms in the numerators. So 1k, and then that would be a minus. Well, actually, let me just write this whole thing out so that you can see it clearly. So 1k plus 3, and then this would be a minus k, distribute that minus sign, a minus 1k, and then a minus negative 3, which makes it a positive 3. So what does that mean? That means we still have 2 times k plus 2 in the denominator, but in the numerator we have 1k minus 1k. So that means that those guys cancel out, and then you have a 3 plus a 3, which is a 6 on top. All right. So this can actually still be simplified. Why? Because 2 goes into 2, and then 2 goes into 6 as well. So we can take that 6 and write it as a 2 times 3. And then we have this in the denominator still, but then we can cancel out 2's right there. And then our final answer is a 3 over k plus 2. And we're done. So that one wasn't too hard because we had the same denominator. Some of them we won't, but let's do a few more. All right, copy this one down. You'll notice that we have, again, the same denominator. Wait, do we? Look closely. Do we? Are all the plus signs the same? The variables the same? The powers the same? Yes, so we do have the same denominators. All right, well, then we just have to worry about the numerators. So we have the n plus 1 and minus 3 on top. Let's do that, combine like terms. So really we have the n that doesn't change, but we have the 1 minus the 3, which is a negative 2. So then we're just gonna write that as an n minus 2 in the numerator, and then a 2n plus 1, and n minus 1 in the denominator. And we don't have anything we can cancel here because this is not the same. N minus 2 is not the same as n minus 1. We can't cancel those. We can't cancel anything else here. We can't cancel the n's there because these guys are married. And we can't cancel the n's there because those guys are married. So we're done. This is the answer right there. All right, how about the next one? Copy it down, please. X plus 2 over 2 times 2x minus 3 plus 3/2. Now, little warning. for you. Okay, before you start a question like this, you always want to ask yourself, can I simplify anything in the beginning? Make it so this might be a little bit simpler of a form, okay? And it just so happens that you can't, but we'll be getting to a problem. Our next problem you will be able to, and I'll show you why. But it's a good question to ask before you start doing anything. Now, in this one, we need a common denominator. We don't have one. See, this one has 2 times 2x minus 3. This one has a 2. So we need to take this and change it into a fraction that has a denominator like this. So how do we do that? Well, remember, whenever you have a fraction, you can scale it up, change it. Well, not add anything to it, not change the quantity, but just change the number of slices by multiplying the same quantity on top and bottom. So the quantity that we're going to multiply on top and bottom of this fraction right here is the 2x minus 3. And you'll see why in just a second. So let's do that. Both on top and on bottom. Really, that's just the same thing as multiplying it by 1, right? So we're not changing the 3/2. It's still 3/2, exactly the same quantity. But now we have two fractions that have the same denominator, right? Okay. So we're going to have to multiply this 3 out. We're going to have to distribute it to both the 2x and the negative 3. So we'll do that. I'm going to stick red. Okay, so let me copy this. And plus 3 times 2x is a 6x. 3 times negative 3 is a negative 9. And then we have our common denominator of 2 times 2x minus 3. All right. Now it becomes a little easier to add. You see how now we have the common denominator. We can always change a fraction to have the same denominator as another fraction by simply multiplying both top and bottom by that same quantity. Okay, I think I've been clear about that. Now we just combine like terms. X, well, there's a 1 here. Don't forget that. There's a 1 here. 1x plus 6x, 7x. 2 minus 9. Okay, that's negative 7. And then in the base, or the denominator, we have, I want to be sloppy. There we go. 2 times 2x minus 3 still. Now, can we simplify this any farther? Well, we can factor a 7 out at the top so that we would have like a 7 times x minus 1, right? And then a 2 still times a 2x minus 3. But there's nothing that can cancel on top and bottom. I mean, these are all married. You can't break these apart. Can't factor anything else out of them either. So we're done. This is our answer.